Hi, I'm Teresa Hansen. I'm the chief editor of Electric Light and Power magazine and Power Grid International magazine. And today I am doing my first Google Hangout. And I am here with Michael Nark. He is the CEO of BuildingIQ. And we're going to talk about energy management systems in commercial facilities. And we're going to talk about what BuildingIQ offers, as well as how that is important to utilities or electricity providers. So Michael, welcome.
Thank you, Teresa. Happy to be here. My first hangout as well, so this should be fun and exciting. Thank you for having me.
You're welcome. We'll see how this goes. So, first of all, I'll just tell our audience that your company provides software as a service. It's a solution that you provide to commercial building owners and operators that helps them optimize their energy use. So maybe you want to just start by telling us a little bit about what you do and what makes you different than most commercial building energy management system providers. I know that energy management systems have been around for a very long time, and a lot of commercial buildings use those. So what makes what you guys are doing different than what's been done in the past?
Sure. First of all, it's a very good question. It's a logical starting point for us. I think the way to level set this very simply is that we actually do not replace at all the building management system that is there. We actually leverage it by essentially utilizing the information and the capabilities that it has, but incorporate into it or take into account real-time parameters for the control of energy that typically are not and have historically not been integrated into, if you will, or brought into the building management system itself. And those parameters for us are pretty straightforward in the marketplace, and it's basically weather, how the weather changes day in and day out, or hour by hour, week by week, as well as the rates or tariff structure that the specific building may have under contract at any point in time. And then last but not least, or I should say next, would be kind of occupancy. So how occupied is the building from, say, 8 a.m. versus 10 a.m. versus 12 a.m. Versus in the evenings. And then last but not least, also the ability to incorporate demand response signals coming directly from the utility for specific load reduction opportunities, et cetera. But all of those are built into a what we call a thermal model, to where we model the performance of the building, and that allows us to predict essentially the amount of energy it is going to use. And that in itself is completely different technology than exists today in the traditional building management space. But again, we're leveraging that existing technology and kind of sitting on top, and you like to call it optimizing. So we're an optimization layer on top of the existing building management system itself. And so we enable control, but we enable that control at a higher level by incorporating what we considered earlier there, the real-time constraints, which is, again, the weather, occupancy, current rate and tariff structures, as well as essentially the ability to actually participate in demand response programs.
Okay, so you're analyzing a lot of the data that already exists, in other words.
Exactly. We're just taking advantage of existing infrastructure, analyzing that data, and really developing a more granular, if you will, optimization strategy around how that building operates.
Okay. Well, it's it's easy to see why that technology would be of interest to facility managers at buildings and different facilities. But as I mentioned to you earlier before we started the Hangout, that most of our readers work for electric utilities, or they're somehow associated with electric utilities and electricity providers. So why would that kind of technology be of interest and be important to that audience?
Certainly. I think there's a couple of reasons, but perhaps the largest reason is because it enables a utility to essentially, first of all, gain knowledge and understanding of how load or electricity is essentially being used out there in the marketplace, particularly in the commercial building space, number one. Number two, by virtue of being able to have that visibility, the utility, because we are a closed-looped optimization system, can then also, frankly, take control of that load, so have the ability to reduce load or usage at a specific point in time during the day. So it is an enabler for a true demand response program or a demand response initiative or event, and allows the utility to go direct to the building versus having to go through an aggregator or somebody like that who would actually reduce the load for the utility. So instead of having to go through a third party, if you will, it allows a direct connection for the utility. That's number one. And then number two, that client on the back end side certainly has the ability to share in the economic viability of the demand response program, but also then gets the benefit of the ongoing energy efficiency capabilities that the application provides as well. So it's really that ability to direct connect and direct control load that is important and is of interest, I guess I would say, to the utilities themselves.
Okay, for this to be a benefit to utilities, do they have to offer a demand response program?
They don't have to, but I think for the most part, utilities who are indeed trying to get visibility and control, and more importantly, first and foremost, visibility of load and how electricity is being used in the marketplace or in their particular marketplace, is first and foremost of importance to them. And so our application helps them do that. By essentially having a demand response program incorporated into that allows an economic factor or a financial factor to be introduced as well. And 9 times out of 10, that is a driver in the marketplace and a driver for utility, but it isn't necessarily a requirement.
Okay. Well, utilities have had people within their own organizations that have worked with commercial buildings and facilities and their managers. So how would this kind of technology and the kind of services that you're able to offer, how is that going to change their jobs when they're reaching out to their commercial and industrial customers?
So our experience to date, we've worked with several utilities with this with our application who have taken on and supported our application. And those specific account managers themselves, mostly on the commercial side, because again, most of our business is focused in the commercial segment, they have actually not seen a negative impact at all or any change at all to their job. And in fact, it's enabled them to quite frankly provide a better level of customer satisfaction to their client base. And for at least the pilots and the initial rollouts that we've done with some of our utilities, that has been one of the major drivers that the utilities are looking for an intangible benefit, in addition to obviously the financial benefit associated with DR, is the ability to provide a better level of customer satisfaction. And they're able to do that through the account managers themselves, because now the account managers are more equipped with exactly how much utilization is happening intraday for that client, and to help them make better business decisions, quite frankly. So it's really a customer satisfaction improvement tool as well as a direct financial driver. And we've seen that be a great benefit to the account managers themselves.
Okay, that makes sense. So is your service typically offered through the utility, or do you also go directly to the facility managers?
It can work. It works both ways, and it is very dependent upon the geographical market and frankly the client themselves. The majority of the time when we're going through a utility, the utility is utilizing our application to, again, as I said earlier, drive a customer satisfaction metric for them, as well as enabling a demand response program to take place. And I think it's fair to say about 50% of our installed base or 50% of our client base essentially uses that manner or is in that approach. The other 50% is a direct acquisition of our software by the end user or the building owner, operator, him or herself. And they're typically using it for basically the energy efficiency benefit that the application provides, where we're able to essentially help them optimize the utilization of the HVAC costs associated with energy spend. So it's about a 50-50 split. I suspect that it will continue on that path moving forward, at least here in North America. Domestically, internationally, we do a good amount of business in Australia. And in Australia, quite frankly, it's a little bit more focused on the end user themselves. They buy it directly. It's probably more like a 70-30, 80-20 split down there, where the direct end user is buying it for efficiency purposes and or sustainability purposes.
Okay. Okay. So, I've been hearing a lot about automated demand response. So is this the type of technology that's going to allow for more automated demand response?
It certainly is. It has enabled open ADR, if we will, right? Auto DR, ADR 2.0B, etc. All of that is there, and obviously it's a lot of buzzwords, but short and sweet, yes, it does enable that. So again, going back to what I said earlier, it allows that direct connection, if you will, from utility to essentially building to allow that load to actually take place. And most importantly, Teresa, it gives the utility some visibility into how, almost like a forecast, the ability to forecast how much load can actually be reduced prior to essentially executing on a demand response event.
Okay. So are time of use pricing or tariffs necessary for this to be worthwhile?
I wouldn't say necessarily. No, excuse me, necessary. But they certainly provide, augment the value that's there. So the obviously time of use rates create certain expense criteria, right, or certain expense ratchets. And by virtue of having those, it's very difficult without our technology to really optimize against those structures or that time of use rate to essentially reduce essentially the overall cost of electricity. So it's not a requirement, but certainly in areas where time of use rates are in play or even significant demand charges are in play, our value certainly increases because essentially we're able to automate it, quite frankly. But it is not it's not a necessity. I would say one other thing too, but where we have areas where there is, let's say, a traditional blended rate or a block rate that's in place, the implementation of our technology actually allows the end user to look at participating in time of use rates, et cetera, because again, we offer the ability to control. And that actually is another incremental benefit to them because that is a way for them to also reduce overall energy expense as well, to move from a more traditional flat rate structure to a variable structure. And our control allows them to make that decision very comfortably, let's say.
Okay, that makes sense. So obviously, time of use rates or tariffs will help meet the full potential of the service and help the end user meet that full potential.
Certainly. I mean, I would even go to the next step that says I would love to see that happen throughout the marketplace because that would drive more enhanced value for our application. So the more that happens, the better off we're going to be, quite frankly.
Okay. So maybe you can tell me what parts of the U.S. anyway are most are best suited for this type of technology, and where do you guys see, where are you using most of this?
Sure. I mean, and simply put, it can be applied everywhere. But as you allude to, I mean, we use the word, probably a poor choice of words, but we look for the low-hanging fruit first, right? Which is where the costs of energy are much higher than they are elsewhere. And as you would expect, that's traditionally along the Northeast corridor. It probably goes all the way down to the D.C. area, Western Washington, D.C. We're seeing some incremental or some interest, if you will, in the upper Midwest, Illinois area, actually up into even Ontario, and then also on the West Coast, specifically, obviously, California, is really where the three geographical areas that that we do exploit today. We will also here in the not-too-distant future essentially have some very good presence both in Texas as well as Florida, where we'll be a little bit more focused around being able to help eliminate demand charges versus true energy efficiency in terms of a kWh reduction. So it's just a different application of our optimization to essentially open up some opportunities both in Texas and Florida for us.
Okay, great. Well, I have one last question here, and that is, I've been hearing a lot about smart grids, connecting to smart buildings, creating smart cities, that sort of thing. So is this the type of technology that's going to allow that to happen?
Smart, right? I think first and foremost, what requires a smart city is first of all to have some type of distributed generation capability. And certainly, as we continue to evolve and expand, we're seeing more and more buildings have distributed generation already on site, whether that's in the form of batteries or solar or something of that sort. And that's the first step to smart. And we like that very much because essentially it gives us another optimization constraint, right, or optimization input into our approach. Specifically, BuildingIQ today being really only focused around HVAC control, or so the ability to actually reduce energy expense associated with HVAC. We're probably not able to exploit that as much as we would like, but as we evolve beyond just HVAC and start looking at total load, certainly having on-site distributed generation in the form of solar, battery, or whatever else may be there enables a lot of that smart grid to take place. And ultimately, the goal is to be able to actually provide a full controllable load profile / usage profile back to the utility to give them really consistency day in and day out, comfort in terms of knowing that there isn't going to be big changes day in and day out, and allows them to effectively manage their business a much more easily and seamlessly. Because as more and more distributed generation comes into play, it's not that that impacts cost from the perspective of how it's generated. The cost is impacted by how do they, as a utility, introduce that back into the grid and allow that to be used. So again, another avenue where our technology can essentially, I'll use the word insulate / help a utility to actually utilize that distributed generation without kind of upsetting the grid, and allowing them to have a very seamless approach to how they actually manage generation.
Yes, I think that's a big thing that's certainly coming down the pike, is distributed generation, you know, prosumers, all that sort of thing. So certainly utilities are looking at that. And then I think also, given the announcement yesterday from the EPA, obviously the capacity is going to be changing as far as where we're getting our electricity from those baseload coal plants to, you know, other sources. So I think that that's a very good point, and I think that utilities clearly are going to be looking for all kinds of ways to help them, you know, meet demand in a very, very dynamically changing environment. So I appreciate you talking to me today. Again, for our listeners, I'm speaking with Michael Nark. He is the CEO of BuildingIQ. So again, thank you for joining me, and this is our first Google Hangout. Thanks.
Teresa, thank you very much. You have a great day.
Thanks, you too. Bye-bye.
Bye-bye.